Welcome back to Talk Tensors. Today, we're diving deep into a paper that's really pushing the boundaries of what machine learning can do. We're talking multimodal open set test time adaptation, or MMO-STTA.
It's a mouthful, I know. But the idea is pretty simple. Making machine learning models adapt on the fly to new info, and importantly, to stuff they've never seen before.
So like if you trained a model to tell cats from dogs and then, bam, you hit it with a kangaroo.
Exactly. And not only that, we're talking about models that use multiple types of data at once, video, audio, text, like us, getting info from all our senses.
Right. It's not just seeing a slightly different dog, it's understanding a whole new kind of animal.
Yeah.
And doing all this in real time as it's happening.
You got it. It's like learning to swim while you're being thrown in the deep end.
Okay, now that sounds like a challenge. So where does this paper we're looking at fit in? What's their approach to tackling this MMO-STTA beast?
This paper is titled Towards Robust Multimodal Open Set Test Time Adaptation via Adaptive Entropy-aware Optimization. They introduce a framework called AEO.
AEO, another acronym. But lay it on me. What makes AEO special?
It all comes down to entropy, which is basically a measure of uncertainty. Think about it. If I showed you a fruit you'd never seen, your entropy would be high GH. You'd be unsure.
Totally. Like, is that a spiky pear? A purple mango?
Exactly. AEO uses the fact that models get really uncertain high entropy when they meet unknowns.
So it's like they're saying, hold up, I don't know this one, gotta learn.
Precisely. AEO has two main parts. UAE, which finds those high uncertainty moments and tweaks the learning process, and AMP, which compares predictions from different data types. Like, does the video and the audio agree on what's happening?
So like a jury of senses. If they can't agree, something's up.
Perfect analogy. UAE spots the unknowns, AMP double checks if everyone's on the same page. Together, that's AEO.
Clever. But how did we even get to this point where we need MMO-STTA? Wasn't machine learning always about dealing with new data?
Well, it's been a journey. To understand AEO, we got to look back at how researchers have tackled adaptation over time.
Okay, hit me with the Machine Learning Adaptation History SparkNotes edition.
Early on, it was all about domain adaptation. Imagine a model trained on perfect lab photos. Then it has to deal with messy real-world pics.
Like recognizing your friend in a dark bar versus a sunny park. Same task, different look of the data.
Right. Then came test time adaptation, where the model had to adjust as it saw new data, no time to prep beforehand, real-time learning.
Constantly evolving, like we do as we experience the world.
Exactly. But then things got wild. With multimodal data, images, audio, text, all changing at once.
Right, because the real world's a sensory overload, not just separate pics or sounds.
And on top of that, we realize sometimes there are things models have no concept of, hence the open set problem. Previous methods choked on this.
So MMO and AEO are like the culmination of years of research, taking it up a notch.
Precisely. But the question is, does AEO actually work? To find out, they put it through some serious testing, so they didn't mess around with the testing. To really see what AEO could do, they built a whole benchmark, a bunch of different data sets, different tasks.
Okay, lay it on me. What kind of data did they throw at this thing?
First up, Epic Kitchens, which is video data of, kitchens, recognizing actions, but filmed in all kinds of different kitchens.
Sounds fun. Why the kitchen focus?
The point is domain shift. It's not just can you see chopping, it's can you see it under different lighting, different layouts, different people.
So making sure it's not just memorizing one specific kitchen setup.
Yeah.
Got it.
What else? Next, they used HAC, which stands for Human, Animal, Cartoon Actions.
Okay, that one sounds entertaining. What, like dogs playing poker?
Maybe. The idea here is imagine a model trained mostly on human actions. Then it sees a cartoon doing something sort of similar. Can it handle that? Big jump in what it knows.
Yeah, a cartoon bird dunking a basketball is going to look way different from a human player, that's for sure.
Right. Then, to really crank up the difficulty, they used Kinetics 100C. This one takes part of the Kinetics data set and adds a ton of corruptions. Blurry video, noisy audio, wind sounds, the works.
Oh, like trying to watch a video on bad Wi-Fi all pixelated and stuff?
Exactly. Testing robustness. Because in the real world, data's rarely perfect.
Makes sense. And to round it out, there was NewScenes, right? That's the one for self-driving car stuff.
You got it. NewScenes uses LiDAR and camera data, testing how well a model adapts between day and night and D even between different countries.
Wait, countries? Hold up. How does that work?
They use data from both the USA and Singapore. Huge difference in driving environments, right? Traffic patterns, types of vehicles.
Wow, so they really did throw everything Andy the kitchen sink at it. All right, drum roll, please. How did AEO do?
It smashed it. Across all those different data sets, it consistently beat the baseline methods. And not just by a little, we're talking noticeable gains, especially at finding those unknowns.
So AEO really lived up to the hype. Seems like a big deal for this whole MMO-STTA area.
Yeah, I'd say so. But what impressed me is it also did great at long-term adaptation, meaning it kept learning over time the more data it saw.
That's key, right? The real world's not adapt once and you're done. It's constant change.
Exactly. And remember that mixed domain thing? Like, imagine throwing Epic Kitchens, HAC, and Kinetics 100C all in a blender.
Dita soup. Sounds chaotic.
But AEO handled it without breaking a sweat. Super adaptable.
Color me impressed. But you always want to know the WHY, not just the what. Did they dig into how AEO was working its magic?
Of course they did. They wanted to understand why those results were so good. So they looked at how the model was actually making its predictions before and after adapting with AEO, specifically the prediction scores it gives out.
So like how confident the model was about each guess.
Exactly. Without adaptation, the scores for things it knew W and things it didn't know, those were all jumbled up. Hard to tell them apart.
Like, is this a cat, a dog, or maybe a platypus?
Perfect analogy. Some other methods even made this worse. But with AEO, those scores became way more separated. Knowns over here, unknowns over there, much clearer.
So it's not just adapting randomly, it's actually leading to more organized thinking in the model. Cool.
Right. And that clear separation is what led to better performance, especially on those unknowns. They also visualized the entropy itself, remember? That's our measure of uncertainty. And a similar thing happened. AEO made a noticeable gap in entropy between known and unknown stuff.
So like AEO is teaching the model to be more self-aware. Hey, I'm really uncertain about this one. It must be something new.
That's a great way to put it. But they didn't stop there. They wanted to make sure AEO wasn't just a one-trick pony. So they tested how it did when you changed up the amount of unknown stuff in the data.
Makes sense. In the real world, you never know how many curveballs you'll get thrown.
And AEO stayed strong no matter how many unknowns there were. A little bit, a lot, it could handle it. Super robust.
Not a picky eater, huh? Any kind of data, bring it on. But every approach has got to have some limits, right? Where might AEO fall short?
That's a great question. You always got to be thinking about the downsides. One thing is, right now, AEO needs multiple types of data. If you've only got, say, images, it might not be the best fit.
Makes sense. That AMP part is all about comparing different sources. No comparison if there's only one source.
Exactly. And it is more computationally expensive than some simpler methods. So if speed is really important for your application, that's a trade-off.
Gotcha. Anything else to keep in mind?
Well, like with any new research, more testing is always good. They covered a lot of bases, but there might be some weird data out there that trips it up. Never know.
True. Research is always a journey. But even so, AEO seems like a huge step forward for this whole MMO-STTA thing. Super clever. And speaking of steps forward, where do you see this research going? What kind of novel notions has this paper sparked for you?
I'm glad you asked, because what's really interesting to me is how AEO uses uncertainty as a strength. It's almost like making the model self-aware of its limits. And that makes me wonder, what if we took that even further? What if, instead of just one model adapting, we had a bunch of them, all using AEO, but each specialized in something different?
Okay, I'm picturing like a team of AI experts. Each one's got its own strengths, but they're also cool with admitting when they don't know something.
Exactly. They could share info not just about the data, but about their own uncertainties. Like, hey, I'm really struggling with this. Anyone got any insights?
A machine learning think tank, bouncing ideas off each other and using that combined uncertainty to learn even faster.
Right. It's like a collective intelligence, but one that embraces uncertainty as a good thing, a way to drive progress.
Now, that's a future I'm excited about. AI that's not afraid to say, I don't know, but then uses that to learn something new. But for now, let's bring it back to this paper. I'm always curious about the nitty-gritty details. What kind of models did they actually use for their experiments?
Oh, they definitely went into the specifics. For the action recognition stuff, they use a combo of slow-fast networks for video and optical flow, and ResNet 18 for audio.
Okay, so a mix of architectures, handling different types of data. And what about pre-training? Did they do anything fancy there?
They did. They used some pretty standard techniques like cross-entropy loss, but also some more advanced stuff like sharpness-aware minimization or SAM and SIMMDG.
SAM and SIMMDG, those ring a bell. But for our listeners who aren't knee-deep in this stuff, could you give us the quick and dirty on what those do?
Sure. SAM basically makes the model less sensitive to little changes in the data, like making sure it's got a solid understanding, not just memorizing tiny details. More robust that way.
So it doesn't get thrown off by a little bit of noise. Like a cat's still a cat, whether it's got its ears perked up or not.
Exactly. And SIMMDG, that one's specifically for multimodal learning. It helps the model learn both things that are unique to each data type and things that are common between them.
So it's seeing both the individual trees and the whole forest at the same time.
Nice. And AEO worked well even with all these different pre-training techniques, huh?
Yeah, that's what's really cool. It shows AEO's not picky. No matter how you pre-trained it, it can still adapt and learn.
Flexible. I like it.
Yeah.
Speaking of details, did they give any info about their overall experimental setup? Like what tools and tricks did they use to make it all work?
They did. They used the Atom Optimizer for most of the experiments, and they were very careful about tuning the learning rates and batch sizes. They even included the pseudocode for AEO so anyone can try it out themselves.
Always appreciate it when researchers share their work openly. Helps everyone move the field forward.
Totally. And they went above and beyond, providing extra visualizations and analysis in the supplementary materials, all the details you could want.
Sounds like they really dotted their I's and crossed their T's. Made a strong case for AEO.
For sure. A really solid piece of research.
All right, well, I think that about wraps up our deep dive into AEO and this whole world of MMO-STTA. It's been a fascinating journey. Absolutely.
Yeah.
But the conversation doesn't end here.
To our listeners, we'd love to hear your thoughts. What stood out to you about AEO? What applications can you imagine? Hit us up in the comments. Find us online. Let's keep the discussion going.
And until next time, keep on learning, keep on questioning, and keep pushing the boundaries of what's possible in machine learning.